Okay, so I thought I'd add a little bit to this, and I'm too lazy to write it out, so I thought I'd record it. Let's see, let me get a pointer going here. So a couple things I want to talk about here is, first off, initially there's no mode in this data set, and the only time that happens is in part C. Okay, so for choice A, no mode. Choice B, there's no mode. For choice C, the mode becomes 35 because there's two of them. Okay, now honestly, in quantitative variables, I think the mode is kind of a worthless statistic. In categorical variables, it's a much better statistic. It's more useful. You see what occurs most often. Okay, so I mean that's Dan LeMay's take on it. For some reason, textbooks love to have you talk about the mode for numbers, and I will never do that. I mean, when you get to categorical variables, by all means, but alrighty. So then what happens? The 25 becomes this 25. Let's see, that 25 becomes a 10. Well, certainly the numbers, that 10 is an outlier. We know about outliers now. And so that'll decrease the mean because the mean is not very sensitive to, mean is very sensitive to outliers and spread, which also means since there's more spread, I mean, that's a much more spread out data set than originally. So the variance and the standard deviation will both increase because of that additional spread. The mean there, these numbers, well, that number certainly is much further away from the mean. It changes the position of the mean, so it changes the differences from the mean. Then the median is something that wasn't talked about, and I'm going to talk about it here. So here the median is going to be, well, I don't know, 1, 2, 3, 4, 5, 6. So the median will be 35, right? That's the middle number. And here the middle number is still 35. And here the middle number is still 35. And here the middle number, there's two middle numbers and two either side, so we'll have to average the two. So, but 35 plus 35 is 35. So the median never changes regardless of what we do with these endpoints, okay? So that makes the median resistant to changes in the extremes, okay? Important step, and I'm gonna make a post about this in a minute here, in chapter 3, in section in week 2. Alrighty, so have I talked about everything? We talked about standard deviation. Well, let's see here. Here, what did we do? We didn't talk about the standard deviation here. We dropped the 25 by 5, but we increased the 50 by 5. So that's the spread is still the same. So that the mean should stay in the middle. If I subtract 5, add 5, that cancels out. So the mean should stay the same. The mean won't change at all. The standard deviation probably will change. I'm trying to think of why it wouldn't, because we increased the spread of the numbers and then we square them. So yeah, so the variance and the standard deviation should both increase here because we did change the spread. And here the variance and standard deviation are going to decrease because we decreased the spread, didn't we? Well, we decreased this. Let's see, this 30 became stacked up there. So there's less variation in the status. And the ends are still big, but because there's this one less, remember how we do the x minus the x bar number and then square? Well, there's one more 0 in the mix. So it's going to be the variance and the standard deviation will be slightly smaller. Okay, I think I've got them all. I hope this helps. Let me know if you need some more help.